We're going to do some problems together like we did yesterday. And then you're going to try some on your own. So solving formulas, we're continuing the notes. So we're going to continue to use all the same rules and strategies as yesterday, but just today's problems will get a little bit trickier. Not much, but a little bit. All right, number 1. We're not starting off too bad, at least. We are looking at 3x equals y, and we are solving this. We are solving this for x. So take a look. Is x alone? No. How are the 3 and the x interacting? Multiply. So what's the opposite of multiply? Divide. So I'm going to divide the 3 away on both sides. So these 3's disappear, and I get x equals y over 3. And that's going to be my final answer, because is x all by itself? Yeah. So again, you could write yourself a little note. Isolate the variable. Again, that means get the variable by itself, whichever one they ask you for. So you've got to read the problem, because most of these are going to have at least one variable. So you've got to figure out which variable too. Okay, looking at the next one, we want to isolate x. Where's x? Here it is. Found it. If x is being divided by 5, yeah. So I'm even going to rewrite it so it looks a little bit nicer. I'm going to rewrite it like this. And you told me do what? Multiply. So I'm going to multiply each side by 5. These 5's cancel. So on the left, all I have is x. And on the right, I have 5 times y. And when we've got something like that, we just kind of smush those two things together. And I think we were having this discussion yesterday too, Mr. Fletcher, with number first, letter second, yep. Right? So put your number first, your letter second. All right, let's look at number 3. We want to get x alone. There's my friend x. Remember, I always deal with what's being added or subtracted first. How could I get rid of a plus 1? Minus 1. Yep, let's subtract 1 from both sides. So I get 2x equals. My 1's go away. Y minus 1. All right, is x alone? No. How can I remove the times 2? Yeah, let's divide away the 2. Again, remembering that an equation is important, and we have to do the same thing to both sides. So this is actually my final answer right here. And if you want to box it in, kind of avoid the stuff that you canceled out, I'm okay with that. So x equals y minus 1 over 2. So again, gone are the days that we got stuff like y equals 10, right? Those were the good old days. And now we're getting formulas and things that have more stuff in them. All right, number 4. We want to solve for x. Here's my friend x. Ooh, this one looks mysteriously like the warm-up. What should we do first? Add the 7. So 3x, these 7's cancel, equals y plus 7. Is x alone? No. Bummer. How can I keep going to get x alone? Yeah, divide away that 3. So the 3's cancel. I'll rewrite this one so it looks a little nicer. X equals y plus 7 over 3. No goodness, Miss Vessel wrote over number 5 a little bit. Okay. We want to get x alone. X is hidden right here. So let's deal with what's being added or subtracted first. I've got a plus y. What's the opposite of adding y? Minus. So I'm going to subtract the y from both sides. So this one cancels. 1/2 x, right? I didn't do anything to that 1/2 x, so it just comes along. These canceled, so it's gone. And on this side, I have 3 minus y. All right. When we have a fraction, we should multiply by the reciprocal. Well, what is the reciprocal of 1/2? 2/1. Is 2/1 really just the same as 2? Yes, no? Answer should be yes, right? 2 divided by 1 is just 2. So these are going to cancel. Boom, boom, boom. Gone. On the left, all I have left is an x. And on the right, what do I need to do with this 2 in this parenthesis? Times it in, right? So, or distribute is the word that we use too. All right, 3 times 2. 6. Minus 2 times y. 2y. How are we doing? Are we moving too fast? Are we okay? All right, the next one has 3 letters. Are you ready for 3 letters? You can do this. We want to solve for x. Here's x. How can I get rid of this 5y that's being added to it? Minus. Yep, so make sure in your own head that you're asking yourself these same questions. So I'm asking you the questions out loud right now, right? But I need you to start asking yourself these questions in your head. Let me box this in, and this was my answer for number 5. Sorry, I'm going to draw a little barricade because number 5 kind of ooched over onto 6's territory. All right, so I subtracted the 5y over. Is x alone yet? No. How can I get x alone? If it's being multiplied by 2, I should divide by 2 on both sides. My 2's cancel. X equals 7z. Sorry, that was going to be a different letter. 7z minus 5y. Oh, I don't know what happened to my y either. Okay, I'm just going to start over. 7z minus 5y over 2. That looks better. How are we doing? Okay. Now, bonus. We've got some more information here. You can remove more than one thing at a time. So this is kind of being more time efficient. If you have stuff being multiplied or divided, you can move stuff all at once instead of doing it separate times. So look at number 7. Number 7 wants me to solve for b. Do you see where b is? Yeah, it's right in here. It's sandwiched in the middle. How is 3 interacting with b? And a and c. How are all those things interacting? They're all being multiplied. So watch what I can do. So this is new. I can divide away all the rest of it at once. So I need to divide away the 3, the a, and the c. I'm going to leave the b, yes? The b can stay because that's the one we wanted alone. So if I do that to one side, what do I have to do to the other? Yeah, the same thing on the other side. So 3A and C. All right, on this side, my 3's cancel. Do my A's cancel? Yup. Do my C's cancel? Yup. So I'm just left with B equals. On the other side, I had D in the numerator, and I have 3AC in the denominator, and that's my answer. So you can sometimes, when you've got stuff being multiplied and divided like this, you can get rid of it all at once. We're going to do the same thing for number 8. We're going to make it a one-step problem. Do you see how A is sitting in the numerator? Is it being divided by the 3, the B, and the C? Do we agree? So I'm going to multiply each side by the 3, the B, and the C. So you can do it all at once. So that way you can get rid of everything. It's like a one-stop shop. Kind of like why we go to Meijer, right? Like you can get your food, but you can also get your paper plates. And then like, ooh, I needed a shirt. And then, I feel like you can get a lot of random things at Meijer. I feel like I've had weird random orders some days. This is a one-stop shop. We can do all the things at once. These all cancel. A equals 3. Yeah, so 3B. C, D. And kind of going along with the conversation we had yesterday, the number comes first, and then when we have lots of letters, like we do here, we put them in alphabetical order. So B, the C, and the D are in alphabetical order. All right, look at number 9. We've got 2 more problems we're going to do together, and then you're going to have some time to do very similar problems on your own. But again, Mr. Fletcher and I are here to help. Although keep remembering, like we've got a quiz eventually coming up. And so our quiz is this week on Thursday. So tomorrow's going to be a review day. And then we're going to quiz. And Miss Bessel's going to make the review worksheet today. Because I don't like that one either. Okay, we're solving for x. Do you see x? It's like sandwiched in the middle, yeah? Do you see it? Yes or no? Yeah. Yes. Okay. How are the 8, the x, the y, and the z all interacting with each other? What are they all being? Huh? Multiplied. So we're going to divide away the 8, the y, and the z. The 8, the y, and the z all at once. 8's cancel, y's cancel, z's cancel. So you said, what, Hayden? What's left on the left? X equals 19 over 8yz. And I didn't quite have enough room, so I wrote a slash instead of like a true fraction. Yeah, that's fine too. My spacing isn't perfect this morning. All right, last one. We talked about this yesterday. We can also use this to solve different formulas, and this can help us with questions that we could encounter in science. So one of the most common formulas that we use is distance equals rate times time. And then to write it even more simply, we write it like this: D equals R times T. Step 1, we want to solve the equation for T. So I'm going to rewrite it. Distance equals rate times time. If I want to solve for T, that means I want T to be alone. Here's T. Is T alone?
Yeah.
It doesn't look alone.
Oh, no.
It looks like it's being a little bit annoyed by R. How is R interacting with it? Multiply. So how could I get rid of the R? Divide. So this is part A, is we're going to divide away the R. Yep, so D over R equals t. So that's my formula now. So notice that it's solved for t because t is alone. Could I also flip-flop it and say t equals d over r? Would this be okay too? Yeah. So you can flip-flop them as well. Part B. How long would a trip take? So we are solving for time. How long would a trip take if you travel 100 miles? Would you plug in 100 for the d, for the distance, or for the rate? The distance. So I'm going to plug in 100 where the d for distance was. So how long would it take you to travel 100 miles at 40 miles per hour? Is 40 my rate?
Yeah.
Yeah, it's how fast I'm going. It's my rate of speed. And then if we divide that on our calculator, if you don't have a calculator, I've got a couple that we can borrow, but again, we've got to start bringing our own as well. What do you get when you divide? 2.5. And we were working in hours, so 2.5 hours would be my answer. So you should be able to look back up into the problem to see what your unit of measure is. All right. If you flip the page over when you are ready, there are some problems hiding on the back for you that should be fairly similar. Go ahead and try